Hello, this is Dr. James Camp at Lee College in Baytown, Texas, and these are my comments on Chapter 6, Functions, of Tony Gaddis' Starting Out with C++. Okay, 6.1, we start by just introducing the idea of modular programming, which is what the concept of functions fits into. Okay, so far we've been writing programs like this, where we have our int main, and then we continue through a long series of statements, and the last one down here would say return 0, presumably, to indicate that we're ending our program with no errors, and that would be the end of the program. It would just be a long series of statements that are all related basically by the fact that they're part of the same program. As you can see, that's kind of an eyesore, but even more than that, it's difficult to figure out what the organization of that block of code is, which statements go together, which statements do related things. So in this program to the right side of the page, the program has been broken down into function 2, function 3, and function 4, and really what you should see here in int main is not statement, 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 but function 2 being called, and then function 3 being called, and then function 4 being called, and then your return 0 statement. Okay, indicating that what we do is first we activate function 2, and then when that returns, we activate function 3, and then when that returns, we activate function 4, and when that returns, we end the program. Okay, this way it's very easy to tell, at least if the program was well written, that these three statements in function 2 go together in some logical fashion. They form a coherent block of code that does a particular function. Presumably, if this program was well written, function 3 would consist of a group of statements that also do a coherent thing, and function 4 would give us yet a third set of statements that do a coherent thing. This is called modular programming. It's breaking your program up into smaller, manageable functions or modules. In C++, we call each of those modules a function. Okay, in any of the C, in C or C++, we call those things functions. In other languages, Java and C#, they call them methods, but they still do the same basic idea. It's a block of code that performs a task, and optionally, I'm going to add this here, optionally returns a result. Okay, so functions can work essentially one of three ways. You can have a function with no parameters that has no return value, just does something. Okay, and because it has no parameters, it would do the same thing every time. There's no way to tell it to change its functionality. You could have function of parameter does something based on the value of param. Okay, so this function would do something different every time. And then we could have return type f, and it could have a parameter or not. Okay, And this one is going to return a value based on param. So this one is closest to what you may think of as the definition of a mathematical function. You may have learned in math that y equals f of x means you input a value x, you process it in some way through the function, and you output a value for y, such that any x will produce a given value of y. That's what functions are named after in C++, is that they can have that same structure where you input a parameter, you process that through the function, and you return a result. Okay, so how do we define and how do we call a function? There are two concepts in C and C++, a function definition and a function call. A function definition is a statement that makes up the function itself, okay? And this will occur once in a program. You never redefine a function. A function call is a statement that causes the function to execute, and this may occur many times, okay? So in pseudocode, we would say define function f of x, do x, y, and z, do steps x, y, and z, return value, okay, and that's our definition. Then later on in our code, we can call f of x we can say a equals f of x1, b equals f of x2. We could even say c equals f of x3 times f of x4 minus f of x5. We can call it multiple times in the same line of code if we want to. Okay, so those are handy. That's a handy snapshot of this is my function definition. All of these are function calls. Okay, the definition includes two pieces: a function header, which provides a return type. Okay, going to look like this. Return type, name, param list. Okay, the param list always goes in parentheses. The function body then is a series of statements enclosed in curly brackets. So that will go after your function header, and it will have statement 1, semicolon, statement 2, semicolon, and optionally there's a return statement that we'll talk about later in the presentation. Okay, so here is a really simple function that we learned way back on the first day of class that says prints hello world to the screen and then returns a value of 0 to the operating system that ran this program. We don't usually think of it this way, but C++ does, that the main function is called by the operating system, by the program loader, as if it were a function of the operating system or something. So if I wrote this in a program called hello.cpp, and I compiled it to an executable file called hello, and at my command interpreter, I type hello. Well, probably I have to type ./hello to tell the command interpreter that that's the version of hello I want to run. The command interpreter is now going to call main in the executable file hello. Okay, and so that starts out our program right there. Runs cout hello world, runs return 0, which passes an error code of 0 back to the program loader to tell it that the program executed fine and exited fine. Okay, now this line, int main, okay, is the function header. Okay, if a function returns a value, the type of the return value must be indicated. If a function does not return a value, its return type is void. Now note that there are a couple of different words used in programming for things that have no value. An object that has no value is called null. Okay, a function that does not return a value is called void. So those are different concepts. We like to say in English that something is, quote, null and void, but those are actually different concepts in programming. Note that we have a return that returns the correct type, an int. For a void, we have no return statement. Okay, typically. We could put in we could type return semicolon without returning a value if we wanted to end the function, explicitly. Usually a void function ends when it runs out of code. When it hits the second curly bracket, it just ends. But we could end the function explicitly by replacing my no return statement comment with the one word return. We'll talk about why we might want to do that later on in the program, in the presentation. Okay, function calls. We've covered function headers and function definitions now. To call a function, you use the function name followed by parentheses and, of course, a semicolon if that's all you're doing on that line. When called, the program executes the body of the called function, whatever's inside the curly brackets for that function. After the function terminates, execution resumes right after that line of code was called. So this function, this simple program here, displays a cout hello from main. Then it calls display message, which is going to run up here. Okay, it's going to cout hello from the function display message. Okay, then at the end of that, we return to right after the display message call, and we cout back in function main again. Okay, so this shows exactly what I was just talking about. The program flow, when you hit the display message call, program flow moves up to the display message function, and when that function is over, program flow returns to the next regular. And we now return to our regularly scheduled program. Okay. Functions can call other functions. Okay, in fact, since main is a function itself, and it can call multiple functions in the course of its life, you already know that functions can call other functions. But if you write a custom function, it can call other functions, either predefined ones like the ones we encountered in CMath, or other functions that you've defined. So you could do int absolute value of a function, okay, to define the absolute value of a function, return something, okay, you'd have to write your code there. And you could do bool is even, okay, which would return true if the number you're looking at is even, and false if it's odd. Well, you might want to start with the absolute value of, so you could say y abs equals absolute value of y, and then you return whatever your code wants to say, okay? So when your main program down here calls if is even of 22, okay, we're going to take 22, pass it up to is even, and then is even is going to immediately pass that value on to absolute value of x, okay, and then that is going to return a value here, and this is going to return a value here, okay. So functions can call functions, and those functions can call functions, etc. Before the compiler can call a function, it needs to know all the things that are defined in the function header. It needs to know the name of the function, the return type of the function, how many parameters, and the data type of each parameter. What I haven't been specifying here in my lazy example programming is that this should have said int absolute value of int x, because we've got to have a data type for our parameters. Okay, so if the compiler has to know the function header before the function can be called, how do you notify the compiler about the function before your program ever makes a call to the function? Well, there are two ways. Probably the more conventional way is to simply place the full function definition before the calling function's definition, okay? But sometimes you have functions that call each other, okay, in a back and forth way. If you had f of x and g of y, and this called this, but then this called this back, you can't have both of them fully defined before you get to the other one, okay? One of them has to be defined first. So a way to get around this is to use function prototypes. The full function definition looks like this: void, print heading, parentheses, open curly bracket, whatever your code needs to do, close curly bracket. There's no semicolon at the end. Notice that, okay? The prototype looks like this: void, print heading, parentheses, semicolon. Okay, this tells the program that you're reserving room in memory for that function, a function called print heading, but that you're not defining it yet. You're going to define it sometime later. You still have to define it sometime later in the program or you'll get a compiler error, but this lets you set aside that name ahead of time. Okay, so the person who writes this, Gaddis, likes this idea of declaring your main function and writing it first, and then writing all of your other functions after it. So, which is not the style I grew up learning, but he defines void first and void second as prototypes here. Notice that they both end with semicolons. And then on the next page of code, he writes your void first, including the open curly, what does it do, close curly, and then he writes void second, including open curly, what does it do, close curly. Note that these are void functions, so they don't have a return statement. They just do what they do, and then the function ends. Some bits of prototype style. It's best to put prototypes near the top of your program. That makes sure that the program knows all the functions that it's going to be defining later, and then whatever order you want to define them in later, the compiler's already been notified. You still must define the function, but you can now place the function definitions in any order. And when I mean in any order, I can have a set of prototypes int f of x semicolon. Sorry, I keep forgetting my int f of int x semicolon double g double y semicolon, and then I can define g double g double y open curly, do my stuff. I can define g first, and then I can define main, and then I can define double f. Sorry, I can't define double f because I defined it as an int earlier. Int f of int x open curly, do my stuff, close curly. So I can define these in any function, any order in the file that I want, as long as the prototypes have been made public at the very beginning of the code here. One way or the other, okay, whether you choose a full definition or just a prototype, the program must define the function header before any calls to the function, otherwise you'll get a compiler error. So you can choose either the style that I learned growing up, which is define all the functions at the very beginning of your file, or you can choose Gaddis' style, put the prototypes at the top of the program, and then define your functions in whatever order you want through the rest of the program. Either is good C++ style. Okay, sending data into a function. This is called passing values. Okay, you can pass the values into a function at the time of a call. Okay, we've already seen an example of this with the power function that we learned for turning A to the B into that. Okay, these are arguments to the function pow. Okay, pow is defined somewhere in the CMath library, and it probably isn't defined with A and B. It's probably defined with base and exponent or something like that. Wherever it's defined, it might be defined as pow base double base double exponent. The value that's passed as argument A is passed into parameter base. Okay, and the value that's passed as argument B is passed into parameter exp. Okay, and then the function can do whatever it does with those to calculate base to the exponent power. Okay, a function with a parameter variable. Once something is passed into this parameter, that parameter can be used like a normal variable anywhere else in the function. Okay, so if I want to display a value, and so I write a function called display value, and it takes a parameter num, I can write cout the value is, and then pass num, as if it were a variable that I had declared in my function. Okay. This is an example of that same idea. We take display value 5, we pipe it up into this parameter int, and what it does, this int is called num. It comes down here to this, the value is num, and so we get this line output, the value is 5. We took the 5 that was passed into num and we display it there. Okay. The parameter in the function header is also sometimes called the formal parameter, or some people, just to be confusing, call it the formal argument. Okay. The argument in the function call is sometimes called the actual parameter or actual argument. Okay, so you have the formal one, which is how it's defined in the function, and the actual one, which is what the value that you're actually passing. The prototype must include the data type of each parameter inside its parentheses. The header must include a declaration for each parameter in its parentheses. And the call must include a value of the correct type for each parameter in its parentheses. So, in order for these to all match up, even or odd prototype only has to say int. We don't have to give it a name yet. We can, usually we do, but we don't have to. The header, which would be followed by open curly, do some stuff, close curly, okay, by the function definition, that has to have not just a type, but an actual name, okay? And then when we call even or odd down here in the program, okay, we have to pass a value in there. Now, does that have to be a variable? No. Okay. We could call even or odd 3, though that would be kind of silly to know because when we're writing the program, we know that 3 is odd. So why would we want to do that? But we could. We could call even or odd x plus 3. So you can actually have an expression, as long as it evaluates to a number of the right type, okay, you can have an expression inside the parentheses. Okay. The value of the argument is copied into the parameter when the function is called. Okay. You don't change the actual value down in the calling function. You make a copy of it. A parameter is in scope only within the function that uses it. Okay, so that int num comes into scope when the function is called, goes out of scope as soon as the function ends. So you can't reference num back in the calling function. A function can have as many parameters as it needs. I've seen functions with 10 parameter lists. You know, there's nothing wrong with that, except that it becomes cumbersome to write them. There must be a data type listed in the prototype and an argument declaration in the function header for each parameter. Okay. And arguments will be promoted or demoted as necessary to match the parameters. So if I pass a double to a function that expects an int, it will get truncated to just the integer part getting passed to the function. If I pass an int to a function that expects a double, which is what happens with all the CMath library functions, then the int will be automatically promoted to a double and the math will continue. Okay. When passing multiple arguments, the number and order of arguments in the call must match the prototype and definition. So if I say int f of double x character c, do some stuff, end, and then down in my code here, I want to call f a 3.14, no. Okay, this would not call that function because the headers do not match. Okay, I have to switch the order here and make the 3.14 come first and the a come second. Now that will be a valid call. And this first, the first argument will be copied into the first parameter. The second argument will be copied into the second parameter, and so on. So if I did have double x, comma, double y, I have to specify x and y in the correct order. Okay, passing multiple arguments. Here's an example of one that takes int, int, and int and adds them up. I think this is a lousy example because it doesn't actually matter what order you put these in. But the point is, we call show sum with value 1 in orange, value 2 in green, value 3 in blue. And so value 1 gets copied to num1, value 2 gets copied to num2, value 3 gets copied to num3, and then they get added and the sum is displayed. Now in this case it doesn't actually matter what order you put them in because addition doesn't care about the added. But if you had minus and times here, then it would definitely matter which order you passed the numbers in. Okay. This is to note that so far what we've been doing is called passing by value. That means when an argument is passed to a function, its value is copied into the parameter. Okay, so if I call f of 3.14, and I'm doing int f of double x, 3.14 is copied into x. Where this becomes important is if I have another value down here called, a variable down here called xyz, and I'm going to copy the value of xyz into f, and anything f does with this value does not copy back to xyz. Okay, so I could write x plus equals 3 here. That's going to change x, but it's not going to change the original xyz. It's not going to make the copy doesn't work backwards. Okay. So we can use functions in menu-driven programs in a couple of interesting ways. One is we could make each user choice from the menu a function. So we could say, if choice equals go, then we call go, else if choice equals stop, call stop, else ... Okay, so each one of our menu items could be a function. Another way we can use them in menu-driven functions is to implement something that every choice is going to do. So if choice equals 1, I forgot my double equals here, lazy programmer. If choice double equals 1, do option 1 here. Report result. Else if choice equals 2, do option 2 here. Report result. Else ... So you see that in each case we need to report our result, and so rather than writing that code multiple times and having to change it, if we decide we want to change how we report the results, we'd have to go to every else if, every if and else if in this whole program and change the reporting code. Instead, we can write one function up here, void report result, that does exactly what we need it to do. And then we only have to, if we make a change in how we want to report our results, we only have to change that code once up here. Okay. Now, I told you we'd come back to the return statement. Here we are. The return statement is used to end the execution of a function or return from the function. Okay. It's usually the last statement in a function, but it can be placed anywhere in a function. Okay. And it becomes the last statement in the function because everything that follows return will not be executed. This is usually done if there's some sort of an error condition that's detected, and so you need to return early from the function, or perhaps there's some function that something that makes it very easy to return a simple answer from that function instead of having to go through all of the function's code. So for example, if I had an averaging function that took a list of numbers and returned the average, if it detected that only one number had been returned, had been passed to the function, there's no need to add up the numbers and divide by something. You just return that one number, right? So real simple. We could do if count equals 1, return number 1. Okay. And then else, we do the process of adding up all the numbers and dividing by count. In a void function without a return statement, okay, has to be a void function because otherwise you need a return statement. The function ends at its last curly bracket. The function just runs until it runs out of code, and then it returns automatically. Okay. So imagine that we're passing two numbers to a function called divide. This is one of those where there's an error code that you need to return. So if the second argument is 0, then you would be dividing by 0. You can't divide by 0. So we see out an error message and we return early from the function. Otherwise, we see out the correct answer and return normally. Okay. Usually, however, when we use the return keyword, it's because we want to return a value. So a function can return a value back to the statement that called the function. You've already seen this with all the CMath functions that we studied. The POW function takes two arguments, a base and an exponent. It does its, whatever calculations it does internally, and then it returns the result of them to be passed into, in this case, the variable x. In a value returning function, okay, a function that returns a value, the return statement can be used to return a value from the function to the point where it was called, okay? So here's, we define a variable of type double called result. Result gets to be num1 plus num2. Take our two parameters and add them. Okay. Now, why did we make result a double? That's a really good question. I don't actually know the answer here. This should be an int to match the int here, the int here, and the int here. Some compilers would even give you a warning about that, indicating that these numbers are all going to be promoted to doubles and then demoted right back to an int. But then we take whatever value has been calculated in result, and we return it to the calling function. Now, notice this is good programming style to declare your variable on one line, do your calculation on another line, do your return on another line. However, if you're pressed for time or space, you could condense this entire line to say return num1 plus num2. Okay, you don't actually have to declare a result variable and store the result in it and then return that. You could just return the sum. Okay, and so you'll sometimes see programmers who are just wanting to save programming space and typing keystrokes and all of that, put the entire function definition on one line here, return num1 plus num2. Okay. See, he even shows you how to do that here. Okay. Okay. So this shows you we're taking total is sum of value 1 in green, value 2 in yellow. So value 1 gets passed here, value 2 gets passed here, and then the sum is returned back up to the calling program. I hate that he breaks this across 2 pages because I can't show you that. But he's got a version of it here. Okay. So return gets passed up to total. Note that I can also use function results, returned results in cout statements. So I could have just put cout, the total is sum value 1, value 2. Okay, so that's a valid, this is valid C++ 2, just sticking the result of a function right into an output statement. The problem with that is you do your calculation and you lose the value immediately. It gets put out to output, but the program never knows what the output is. This is usually better style here because you store the value somewhere and you can use it again later if you need to. Okay. Another example, area equals pi times square of radius. Radius gets copied into number. Number gets used twice in this case to get number times number. And then the product of number times number is returned and fed into this equation. So it's multiplied by pi and the product is stuffed into area. Okay. Returning a value from a function, the prototype and the definition must indicate the data type of the return value. it cannot return void. Okay, if it's got a void value, you can't return a value. The calling function should use the return value in some way, either assign it to a variable or send it to cout or use it in an expression. You can have multiple function calls that return values on the same line. You can say int y equals f of x1 minus g of x2 times h of x3. Okay, so you can include multiple function results. We would pass a number into x1, pass a number into x2, pass a number into x3, get the results passed out, and those results would be multiplied and subtracted and etc. And the whole function, the whole expression would be evaluated the normal way. Okay, it is sometimes useful to return a Boolean value. Okay, if you define a function with the prototype bool f of, say, int x, okay, then the function can return one of two values, true or false. Okay, the function body must contain a return statement that returns a value of true or false. Okay, note that true is equivalent to 1 and false is equivalent to 0. So you could have an integer calculation that returns either a 1 or a 0. But typically, when you write a bool function, you want it to return the literal value true, the literal value false, or the result of an expression that does the same thing. So you could say return x is less than y, and this will either be true if x is less than y or false if it's not. Okay. So is even would apparently return true if the value is even, false if it's not. And we can see that that's here. If the number %2 equals 0, status is true, else status is false, and then we return our status variable. We could even do that with that one line C++ return num %2 equals 0 question mark, true if it is, not a semicolon, true colon, false if it is not. So we can put that whole thing on one line. Again, C includes a lot of these shortcuts that let you throw an entire set of program logic into one line. That does not mean that is always the best style for C++. This is arguably better style because it's easier for a casual programmer reading through the code to know exactly what's going on. But this is totally legit C++, does exactly the same thing, and saves you a few times of hitting the return key. Okay. Local and global variables. Variables defined inside a function are called local, meaning just like we say, food grown in the same city that it's sold is local food, variables defined inside a function are local. That means, however, they're hidden from statements in other functions, okay? And because variables defined in one function are hidden from variables in other functions, you can often have multiple functions with the same name. So there's a num here and there's a num defined here. They're two different variables. They point to two different memory locations, and they're each private to the function that they're in. So if we cout num here and cout num here, we get different results depending on whether we're in main in another function or back in main. Okay. A function's local variables exist only while the function is executing. Okay, so this is known as the lifetime of a local variable. When the function begins, its local variables and its parameter variables are created in memory. They're actually pushed onto something called the call stack. And when that function ends, those things are popped off the stack and they cease to exist anymore. That means that any value stored in a local variable is lost between calls to the function, unless you make it a static variable, which we'll talk about a little bit later. A global variable is a variable defined outside the call stack. It's defined before any other code in the program is executed. So it's outside the scope of everything, so it's in scope for everybody. Okay, the scope of the global variable starts when it's defined at the top of the program and goes for the includes all the other functions in the program. This is bad style. Okay, using a lot of global variables makes your program difficult to debug. It's very easy to define a global variable, int x, and then later down here in main to define another int x, and it's not clear to the reader which x is being used. It's clear to the compiler. This one's more in scope than this one, so this one gets used and that one does not. Is that what you meant? Maybe, maybe not. Okay, so that's a downside of using global variables. What a lot of people use globals for are constants. Okay, so in a business program like this one here, your pay rate, your base hours, your overtime multiplier, those are constants that are defined presumably by the person who pays the programmer's salary. The programmer doesn't get to choose those. So they're defined at the beginning of the program and they're used, they're available for any functions inside that program to use. This is something we'll do a lot of in engineering programming, that if we have certain parameters of our system that we're simulating, we have a spring constant, we have certain things that are true constants, like the acceleration due to gravity, or the ideal gas constant, or things like that. We can define all those constants up in a global constant block at the beginning of our program, usually right after all of our includes and usings. Okay, and before we start actual programming. Okay, and that means these constants are true constants. They're going to be the same anywhere else in our program, and they'll be available to all of our functions. However, you've got to be careful not to redefine those somewhere else and come down here and, int min has base pay. If somebody had defined that as pay rate, that would override the constant, and that would cause all sorts of headache, right? Okay, so this shows how you can use those global constants. If hours greater than base hours, base pay is base hours times pay rate. Overtime is hours minus base hours, pay rate times OT multiplier. Okay. Local variables are not automatically initialized. Okay. Inside a function, so inside int main, for example, if I just declare int x, x is not initialized, and that means that int will hold whatever, it means that x will hold whatever value was already in memory at the location that was chosen to put x in. So it's going to be a random bit of crap, really. Okay. Global variables, on the other hand, if I define up here ahead of int, ahead of int main, if I define int y, this is auto init to 0. Okay. Because these are defined at the beginning of the program, there is nothing in that memory location prior to defining that. So these are defined with empty memory locations. Okay. You can have local variables that are static. This is a unique concept for C++ as far as I know. Local variables only exist while the function is executing. When the function terminates, the contents of those local variables are usually lost. We talked about that. They get plopped on the stack. They get put on the call stack. So we get parameter x. As long as the program is executing, it exists. Then it's removed as soon as the function ends being called. Static local variables retain their contents between function calls. They're not allocated on the call stack. They're allocated kind of with the global variables. So they're only initialized the first time the function is executed. 0 is the default value, but you can initialize them your own way if you want. In this case, so we see that int local num is not defined as a static, so when it's changed, that value is lost as soon as show local disappears. So the first time show local is called, it's set to 5. The second time show local is called, it's still 5. It's set to 5 again, rather. Okay. If we define it as a static int, okay, then each time the program is called, we're going to plus it. So it's 0 the first time, 1 the second time, 2 the third time, and so forth and so on. So if you want something that only exists inside a function but persists from one call to the next, you can make it static. Okay. You can also initialize a static to something other than 0 just by putting an equals after it. However, this is only initialized the very first time the function is run. After that, any changes you make to it are accumulated from function call to function call. I've actually never used that functionality, but it's cool to know that it's there. Okay, default arguments. When you define a function, sometimes you don't want to specify all the parameters. Okay, in that case, you can give some of them default arguments. So if you want to say have a sum of a variable number of numbers, you can set the default argument for each of them, everything but the first, to 0, and then it adds up as many numbers as you pass in. Okay, if I pass in a number here, 2 say, and then I pass in a number 3 say, that will override the default and set that to 3. But I don't have to pass something to this next one, and so get sum will just be 2 plus 3 plus 0. Okay, so I could write a get sum with up to 10 arguments, all of which are default 0 except the very first one, and then no matter how many I can pass between 1 and 10, and anything I don't pass will be automatically set to 0. So this one, both of these have default arguments. So this is a function that will display this many stars in one row and this many green number stars in a row, yellow number rows. So by default, it's going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but you can override that. So this one, first time we just call the default, we should get 10 stars in a row. This time we call with one parameter, so that overrides 10, we should get 5 stars in a row. The third time we override both default parameters, we should get a 7 by 3 grid. And you see that's what we get. We get 10 the first time, 5 the second time, and 7 by 3 the third time. If default arguments don't make sense to you, you don't have to use them. There's never a situation in C++ where that's the only solution to a problem, but they can make your life easier if certain situations arise that it would be useful to have a default argument. More importantly, you need to understand that other functions that you may be calling yourself, functions that you may be using from somebody else's library, someone else may have written them with default arguments. And this is true of a lot of the things in the C++ standard library. They've been written so that you can just pass a single parameter, but if you want, you can specify other options by passing additional parameters. Note that if you're going to have default arguments, they have to start at one point and continue for the rest of the function. You can't have a default argument and then not have one here. This is a no-go. Okay. Similarly, when you start calling arguments, you can pass 1 to the first, 1 to the second, and nothing to the third. You can't pass 1 to the first, nothing to the second, and 1 to the third. Okay, this situation is another no-go. So C++ will look for something to fill the first spot, something to fill the second spot. If it doesn't see anything in the third spot, it will assume that you want to go with the default argument. Okay. Using reference variables as parameters. We've talked about passing by value before. You can also pass by reference, and that means that you refer to the original variable, and that allows the function to modify the values in the calling environment. Okay, it's usually used as a way for a function to return more than one value, because C++ functions can only have one return value. So if I'm trying to get the dimensions of a room or something like that, I need a height and a width. I can't have just a single return value. So I pass a value by reference for width and a value by reference for length, and it returns me the values. Note that when you do this, you have to call it as get dimensions length width. Okay, I have to specify these must be variables. I can't pass numbers, I can't pass expressions, I have to pass variables because it's a link to this variable that's being passed, and it's a two-way link, so that if I make a change here, that change is echoed back down here. Okay, the way you do this is by putting an ampersand between the type and the parameter. Okay, it's conventional to put a space between the type name and the ampersand, but that's not important. You must use the ampersand in both the prototype and the header. Okay, so if I want get dimensions, I can say double ampersand double ampersand semicolon. Then later on when I define the functions getDim, I have to say double. I still have to put the ampersand in with double ampersand length. Okay. Use when both necessary and appropriate. Okay. Don't use when the argument should not be changed by the function. Okay. Don't use this when you're just passing values to inform the function, but you don't want changes to come back. Don't use if the function only needs to return one value. It's better C++ style to say x equals f of x than to say f of x ampersand. It's better to take a pass by value and do a return than to do a pass by reference. Makes your function more generically usable too, because in this system you could then later see the need to say x equals f of x plus 1, and that's legit. If you had done this as f of double ampersand x, that function call wouldn't work because that's not a single variable that you're passing. Okay, one of my favorite topics, overloading functions. This is something that not all programming languages can do, but C and C++ definitely can. Overloaded functions have the same name but different parameter lists. Okay, a good example of this is if you want to average some numbers. Okay, I've done this in a program before. Average of x comma y is really easy to calculate. You return x plus y over 2.0. Okay. Average of x, y, z is easy to calculate. Return x plus y plus z over 3.0. Okay. Those cost me almost nothing to write, and they cost the computer almost nothing to run. There's no loops necessary, nothing fancy involved. But if I get average of a list, okay, then I have to do for x equals 0, x less than list size x plus plus sum plus equals list at x, then sum div equals list size, okay, or I return, this is better style, return sum divided by list size. Okay. So I've now created 3 functions called average. The compiler will determine which version of the function to call based on the argument and parameter lists that I pass. Okay. So if I call average of 2 comma 4, okay, it's going to pass 2 to x, 4 to y, and run this version of my thing. If in the next line I say average 3, 6, 9, it's going to see that I have 3 parameters. It's going to pass them to x, y, and z and choose to run this version of my function. Okay, so if you had things that have different sets of dimensions, you could um, create overloaded functions that had different number types, different number and types of uh, arguments and parameters, and the compiler would choose automatically based on which one is the best match. Okay. Um, Another way is if you happen to know, um, is if it happens to be better to do math within a certain type. Um, Here, there's one square function for int and one square function for double. And they both return number times number, but one of them is doing integer math and one of them is doing floating point math. And so it actually does make a difference. The integer math runs through your computer slightly faster than the floating point math. So letting the program choose to do integer math, if you're only worried about integers, then um, that will ever so slightly speed up your program. Okay. There's an exit function that terminates the execution of a program. I'm not sure why we're throwing that in right here, but okay. It can pass an int value to the operating system to indicate the status of program termination. This is essentially the same as return with a number in your int main, except that this can be called from any function. So if you have any kind of error that happens in your program, a divide by zero or something like that, that you have to just terminate the program, you can pass a value to the operating system to indicate that you had an error and you can terminate the program right there. It does require the C standard lib header file, so you've got to pound include that if you're going to use it. Okay. Exit 0 is the exit with no error. There's almost never a reason to use that because if your program is exiting normally, it should be exiting at the end of the program, not somewhere randomly elsewhere. That's another thing that makes your program hard to debug and shouldn't really be used. But you can define several failure codes, or maybe your operating system has already defined exit failure codes for you, so you can exit with the predefined failure code for divide by zero error, and it will tell the user what happened. Okay, last bit here. If you're testing code and you haven't written the full code yet, there are things called stubs and drivers that you can use to test your code. A stub is a dummy function used in place of an actual function. Usually displays a message indicating it was called. So if you're in the middle of writing a program and you know that average of a list needs to be done, but you're just not ready to write the code to average that list yet, you can see out we would be averaging here and return 0, because presumably this would be a function that returns the average. So you just return a dummy value. 0 is going to set everything in the program to 0, so maybe we return 1 just to have a useful value. But that's a stub, okay? A driver is a function that tests another function by calling it without necessarily having anything useful for it to do. So if you have written your average function, you want to make sure it works, you can write a driver that says call averages, and you have a series of cout statements that average of 1, 2, 3 is average of 1, 2, 3. Okay, and you keep doing that for as many test cases as you want to test, and then you get to see when you run your program exactly how average is working for you. Okay. Wow, that was a long presentation. Sorry to have taken so much of your time, but functions are an important topic and we needed to cover them properly. Okay. As usual, if you think you learned something, leave me a like and give me your comments in the section below. Next time we'll be up here talking about arrays and vectors in C++, how to deal with more than one value at a time.